Good morning, everyone. Today I'll be talking about two major types of strokes and focusing on the treatment of ischemic strokes with a drug called tissue plasmogenic activator or TPA. To start, strokes can arise from two very different events. Ischemic stroke, which account of 87% of all strokes, is caused by a blockage on a blood vessel that supplies blood to the brain. The other, an hemorrhagic stroke, occurs when a blood vessel ruptures, often due to aneurysm or arterioaneurysm malfunction, leading to a bleeding in the brain. Each of those has very different cause and treatment strategies. Let's take a closer look to ischemic strokes. Ischemic strokes happen when a blood clot blocks the flow of the blood to part of the brain. Without oxygen, the nutrients, the brain tissues begin to die. There's two main zones affected: the infrared cord, which is the area of severe and permanent damage, and the penumbra, which is less damage and potentially salvageable if it's treated quickly. An important first line of defense is aspirin, a familiar over-the-counter anti-inflammatory, which helps preventing further clotting. Now, the focus of the treatment for ischemic strokes is a restoring blood flow. This is where the TPA comes in. The TPA is the only FDA-approved clot-busting drug for ischemic strokes. So, how does this work? The TPA binds to the fibrin, which is the protein mesh that holds the blood clot together. Once it's attached, the fibrin of the TPA convert the plasminogen into the plasmin, and enzymes that actively breaks down the fibrin and dissolve the clot. This allows the blood to flow back to the affected area of the brain. What is important here is the targeted action of the TPA. It works directly at the side of the clot, ensuring the plasmin is the only product where it is needed, avoiding unnecessary breakdown on other proteins. Now let's talk about the structure of the TPA and how it's allowed to function effectively. The TPA is a syringe protease, which means it has an active site that can catalyze proteins breakdown. The structure of the TPA includes affecting domains that helps bind to the fibrin into the cloth, ensuring its action is located. Once the TPA binds, the breakdown of the cloth is initiated, and as plasmin degrades the fibrin, the cloth dissolves, restoring the blood flow from the brain. Timing is really critical here. TPA must be administered within 3 to 4.5 hours window from the onset of the symptoms to be effective. Outside that window, there's an increased risk of complications like hemorrhagic transformation due to a fragile and damaged brain tissue. On the other hand, the hemorrhagic stroke, the problem is in a clot. It's a rupture of the blood vessel. The TPA is not used for these strokes because the last thing that we want is a clot to dissolve in this situation. Instead, treatment focuses on controlling the bleeding and reducing the pressure within the skull. This highlights why it's so important to diagnose the type of stroke quickly because the treatments are entirely different. To summarize, ischemic strokes occur due to blockage in the blood vessel, and TPA is the key treatment that works by dissolving the clot at molecular level. It targets the fibrin in the clot, breaking it down, and it helps restore the blood vessel flow back to the brain. However, the TPA must be administered in a very short time frame to be effective, making it rapid diagnosis and treatment essential in reducing the long-term effects of a stroke.